Alright guys, welcome to Algebra 2. This is 2.2.3 and we're going to be going over transformations of functions again. So we're going to focus first of all on this kind of recapping of the four kind of ways we've seen to transform functions thus far. So the first one, if we want to add to the outside, right? So if I put a plus k on the end of any kind of function, right, it'll move up or down by k. So if it's like plus 3, it'll move it up 3, minus 5, it'll move it down 5. On B, if I put a negative in front of it, it's going to cause me to have a vertical flip. So I will vertically flip over that y-axis. And then on C, so over the x-axis. And then on C, if we put a minus h on the x, and that has to be as close to the x as possible. So typically you want to put it in parentheses a around the x. And then that will cause it to do a left-right shift by h, where that this is x minus h, where up a above was x plus k. So if it says x minus 3, it'll move to the right 3 as opposed to left 3. So it's a little bit of the opposite of what you would naturally think, but just kind of keep that one in mind. And then the last one we've gone over in the past has been multiplying the front by some value. So if we multiply that by 3, it'll be 3 times as tall. So all your y values are 3 times larger than they normally would be. If you multiply it by 1/4, every y value is 1/4 of what it normally would be. So you're gonna just kind of scales that y-axis by whatever the a is. So those are the main ones we've gone over thus far. So I want to investigate this next one, right? What if we put that negative not in the front, but if we put it on the x itself? Okay, so you are going to want to put it in parentheses whenever you do a substitution for it. So I want you guys to actually do this a little bit of an exploratory thing, so try it out on your own. So using Desmos, take as many different parent functions as you know. On one line, graph the parent function. On the second line, graph the parent function, but put the x negative but inside of parentheses and see what results you end up getting. You're going to need to do that with more than one or two of them, because there are some of them where you're not going to see much of a change at all. But the more you do it with, you should hopefully see what is actually going on and what change that is causing. So go ahead, pause, try that on Desmos, and then come back here. All right, so I'm going to pull up my Desmos tab, and we're going to go ahead and investigate this. So if we did like x to the second, that's probably one of the first ones we would do, right? And then x to the second, but I'm going to put that x negative in with parentheses. And I get the exact same graph. And that kind of makes sense, right? Because if I plug in a 2 and then I get negative 2 squared is still positive 4. So it's still going to turn positive, so I really see zero change there. So that one really doesn't help me much at all. What if I do x to the third? That's another pretty easy one. So I'm just going to change this 2 to a 3. And okay, now I am seeing a change, right? Because if I have a negative raised to a third power, I'm going to stay negative. Whereas if I had a positive, I would stay positive up here. So this is going to actually change things. So visually, I have the same shape, but my blue graph is kind of reflected, right? So it's kind of doing this shape when my red one is doing that one. So you may say, well, that's doing the exact same thing as if I just put the negative in front. And truth be told, that's true. If I did that without the parentheses, I get the exact same graph. Okay. That's not always going to be the case. So let's go ahead and keep on trying. That's why I say try as many of these as you can. What if we do square root? So if I do square root of x, I'm going to put a negative in front of the x, and you don't have to have the parentheses here because it's already under the radical, but it doesn't hurt. And here I see something different, right? So it's a reflection, but it's not the vertical reflection we're used to. This is actually a horizontal reflection. It's been reflected over that y-axis, so it's gone this way. So, well, what if I put the negative out front? That's the vertical reflection. So we are getting a different result there. And that's probably one of the easiest ones to actually see what is going on, because it's not as symmetric as a lot of the other graphs are. So let's go back to that x to the third. So we said, hey, this looks like a vertical reflection, but really, wouldn't that be the same thing as a horizontal reflection, right? If I take this red graph and I reflect it over my y-axis, I'm going to get my blue graph. So what's actually going on is this is a horizontal reflection. This graph just happens to be the case where a vertical reflection gives me the same result as a horizontal reflection. Now those are a special type of function, and we're going to go over that here in a little bit, but that's one thing that I kind of want you to note. So some other functions we might be able to try is we could do the absolute value of x, and if I do the absolute value of negative x, well, I get the exact same graph. But let's think about our rule that we just kind of thought of, right? If I were to reflect my red graph over the y-axis, wouldn't it just go back onto itself because it's symmetrical over that y-axis? So I'm still doing the reflection, but it just visually doesn't change anything, right? And then one of the last ones that we could do would be an exponential. So I do 2 raised to the x. So I do 2 raised to the negative x. So here, once again, we're seeing, yeah, we're going to be reflecting it over that y-axis. So we're seeing multiple times where it's showing that. That's probably the case here, and in truth, it is. So we've kind of found our rule for what that negative does. And that should be kind of falling in line with what we've seen in the past, right? If I put a negative on the outside, it was a vertical flip. If I multiplied on the outside, it was a vertical expansion or contraction. If I put a negative on the x, it does it horizontally. So you could probably make an inference as to what multiplying on the x on the inside is going to do. It actually does a horizontal expansion or contraction. We're not going to get onto those quite yet because those can be a little bit more messy, but that is in general what they do. Okay, so let's hop back over here. And for part B, for each of these, we're going to substitute in negative x and the next algebraically and simplify the result. So I'm going to do that on Desmos just to kind of make it a little bit prettier, right? So this one stays as is, right? If I did x to the second and negative x to the second, right? I can think of it as this being a -1 times x to the second power, and I can square the -1 and the x separately. Well, what's -1 squared? It's 1. So this is the equivalent to just being x squared, right? What if I did x to the third and negative x to the third, right? Well, here, same thing. If I do this, right? Well, -1 to the third power, that's going to be a -1. And then x to the third is going to say x to the third. So that's like a -1 times x to the third. If you really don't always put that one there, it's like just saying -x to the third. Right? So we're seeing that, yeah, if it changes back to itself, like here, it doesn't really show differently on our graph. But on ones where it does change, we are going to see a different graph there. I'll clear out some room here so you don't have to see so many graphs on top of each other. What if we then did square root? And if I do square root of a negative x, now your first instinct might be, well, you can't have a negative under a square root. Well, we won't if our x values are negative, right? Because if I have a negative, it'll work out. We really can't make this look all that much better. We could do a -1 times x there, but it doesn't really help us much. So we can just leave that there and say, hey, we really can't simplify that more. What if we look at the absolute value? Right, I know this doesn't have the fancy symbols, but it's just a little bit easier just to type it out. Versus the absolute value of negative x. Well, if I plug in a positive or a negative in for this x, right, all this negative is going to do is change the sign from negative to positive or positive to negative. But then my absolute value just makes it negative, just makes it positive no matter what it is. So really, it doesn't matter what sign I put here because the absolute value will disregard it entirely. Right? So that's why this ends up being equivalent to just being the absolute value of x. So you see the exact same graph on that one. I think that's all the ones we covered. So you could also do it for a cubic root, but you've seen that enough. I think we're going to call it good there. All right, so hopping back over here, what we kind of found on part C, we already kind of mentioned this. Geometrically, we're getting a horizontal reflection over the y-axis. So that is what is caused by that negative x. So now 123, this is the big kind of culmination part for this particular section. We're talking about what are called even functions and what are called odd functions. Now there is a reason why they're called even and odd, but it is not as hard and set of a rule as you might think, so we really don't talk about that much. You might kind of discover some things about that, and we will go over why they're called that in the future. But for right now, I want you to focus on the definition for how we determine if they're even or if they're odd. So I'm going to go over the formal definition, and then we'll talk about what that looks like on Desmos. So for an even function, we have it's all the functions where f of negative x is the equivalent to f of x. Okay, so what that means is if I do a horizontal reflection, right, it's the same thing as if I did nothing to it, right? And we saw that, right? The absolute value function, if I put that negative in there, it didn't change the overall graph. And the x to the second, if I put that negative in there, it didn't change the overall graph. Those are both even functions, right? For odd functions, if I put the negative in there, it's equivalent to putting the negative on the outside. So this is doing a horizontal reflection. This is doing a vertical reflection. So this says, hey, if you do a horizontal reflection, you get the exact same result as a vertical reflection. Now, which of our functions did that? Well, the x to the third did, right? So if we hop back over to Desmos, we can see that a little bit more clear. So if I have x to the second and negative x to the second, and then negative x to the second. So these are the three things we're kind of looking for, right? The original, the x on the inside, the x on the outside. Now, if these two were equivalent, it would be odd, right? They're clearly different, so it's not odd. But if these two are equivalent, then it's even. And yes, these two are the same graph. So it's going to be even. And then the last case, which is this kind of the other case, is if it's neither of those, then it's neither, right? If it's not even and it's not odd, then it's neither even nor odd, is all we really say. So what if we check this with x to the third? And so here, these two are not the same, so it's not even. Okay, and then these two are the same, so it's going to be odd, right? And then what if we did something like square root of x? So if these two were the same, then they would be even. They're not, so it's not even, right? If these two were the same, then it's odd. Well, it's not odd, so it's going to be neither, right? So graphically, it's really, really easy to check. If you want to check this out algebraically, you just plug in the negative x and see if you simplify it out and it gives you the exact same thing as the original. And then that would be even or not even. And then for odd, you plug a negative in for the x and simplify it, then put a negative on the outside and simplify it and see if those two things give you the same. And if that's the case, then it's going to be odd. And if neither of them are, then it's going to be neither. All right. So that's in general what even, odd, and neither means. We don't expect you to be a massive expert on these quite yet, but but in the future we're going to be doing these more and more and more. So let's take a look at these three functions. We have negative x to the second plus 5. We have x minus 3 to the second, and we have x to the third plus x. So let's go over how we can determine are these even, are they odd, or are they neither. So I'm going to do this on decimals. That's kind of my preferred method for doing these. So my first function is negative x to the second plus 5. So I can look at it, and I can usually determine just by looking at the graph, is this even, is this odd, or is this neither? So if it's even, then the original graph is equivalent to the the horizontal reflection of it, meaning it's symmetrical over the y-axis. Is this graph symmetrical over the y-axis? Yeah, right? If I were to do a horizontal reflection, I would get the exact same graph. Now, you don't have to do this, but if I were to type in negative x to the second plus 5, I get the exact same graph, right? But you could probably determine that just by looking at it and saying, yeah, that's going to be reflexive over the y-axis, so it's going to be even, right? And if it's even, it cannot be odd, so you don't need to check odd. So we're done, right? All right, next one. We have, in parentheses, x minus 3 to the second. So here, is this one going to be reflexive over the y-axis? Well, no, right? This is a symmetrical graph, right? But my axis of symmetry is over here at 3. It's not through my y-axis. So if I were to reflect this over the y-axis, I would move my vertex over here, and I would get a different graph out of it, right? So it can't be even. Now, if it's odd, then the horizontal reflection gives me the same result as the vertical reflection does. Now, a horizontal reflection, I would get a graph right over here, right? I would get that parabola. And if I did a vertical reflection, then I would get a parabola down here. So those are also going to be different. So it's not even, it's not odd, it's got to be neither in this case. And again, you don't need to go and graph the other ones, but I'm going to do it just to kind of show. So we have, here would be, if I plug in a negative for the x, and that's what we predicted, we'd have the parabola over here. If I throw a negative on the outside, I'll just copy paste. Then I get it reflected down. So it's going to be neither in that particular case. All right, and then our last one we have is x to the third plus x. Oops. X to the third plus x. So here, just looking at the graph here, if I were to reflect this over the y-axis, would I get the exact same thing? Well, no, right? Because a reflection over the y-axis would look kind of like this, right? It would kind of follow that same curve, but start on the top left and move down to the bottom right. So it's going to be different. So it's not even, right? We're there, we're good, right? Well, is it odd? Well, to check that, is the horizontal the same as the vertical? My horizontal looks like that. Well, what would my vertical look like? Well, this would go down here, so it would look kind of like that. Hey, that looks like about the same thing. And yes, it is. This one's going to be odd. So just double check it just to be safe here. So if I do a negative x to the third plus negative x, that's the shape that we predicted. And if I do the same thing, put a negative in front, I do need to put it in parentheses because there's two separate things, because it's the entirety of this being made negative. I don't want it to be the same color as the original. So, so we're seeing, yep, those are the same graph, right? So it's going to be odd, okay? So graphically, it's a lot easier to kind of just tell it as long as you kind of keep in mind those rules. Even, it's reflexive over the y-axis, and you get the exact same thing as the original. Odd means your horizontal and your vertical reflections give you the same result. and neither is if it's neither of those two cases. So with that, here is our homework for 223. I'm doing 125 through 131, and I will talk to you guys next time.